Hello there, AP Stats students. We're going to take a look at section 4.3, which is using studies wisely. There's some things that we have to do that we've talked about before about collecting data appropriately and correctly, but then what do you do with that information? Yeah, we're going to analyze data, but what do we do after that? Okay, so first we want to look at this question here. Two essential features of all statistically designed experiments are. So compare several treatments, use double-blind method. Compare several treatments, use chance to assign subjects to treatments. Always have a placebo group, use the double-blind method. Use a block design, use chance to assign subjects to treatments. And then use enough subjects, always have a control group. Now, a lot of those things can be done and are important, but they're not essential for every single experiment. There are certain experiments where double-blind is not necessary because it's a very objective thing. So we would want to exclude, that's not essential. So any of those answers with double-blind, some experiments need double-blind, but some do not. So that's not crucial. It's not essential. The other thing is block design. We don't have to have a block design if you're not trying to compare different characteristics. If you're segmenting on gender or race, yeah, that's important. We would need a block design, but sometimes that doesn't matter. We're not looking at that. That's not of interest. So then that one, block design and double blind, kind of eliminate three of our answer choices. So we're really looking at letter B and letter E. And letter E is the correct answer because you have to have enough people. If you're only having 2 or 3 people in your experiment, it's not really, doesn't matter whether you're comparing the treatments or you've randomly assigned them to the treatments. So you have to have enough people, and you always have to have a control group. So part B says compare several treatments. You might not be comparing several treatments. You might be just doing one treatment versus a control group. That may be a placebo, or that may be, the control group may not get anything. So letter E is the correct answer there. So using studies wisely, we want to draw conclusions. The reason we're collecting data is so we can make connections, we can infer. So that's what we want to try to do here. So looking at these, the type of inference that can be made depends on the design of the study. So when we look at the U.S. Census Bureau carries out a monthly current population survey about 60,000 households. Their goal is to use data from these randomly selected households to estimate the percent of unemployed individuals in the population. And then this other example, scientists perform an experiment that randomly assigned 21 volunteer subjects to one of 2 treatments, sleep deprivation for 1 night or unrestricted sleep. The experiments hope to show that the sleep deprivation causes a decrease in performance 2 days later. So in the Census Bureau survey, it is safe to make inference about the population based on the results of the sample because random sampling was used to choose from the sample from the population. In the sleep deprivation experiment, volunteers were randomly assigned to each treatment to ensure the 2 groups are as alike as possible. If the difference between the 2 groups is too large to be explained by chance, we know one treatment is better than the other. Thus, inference about cause and effect can be made. However, the use of volunteer subjects limits scientists' ability to generalize their findings to some larger population of individuals. So this chart below is going to be very important to us. There's 2 different pieces. Were they randomly selected and were they randomly assigned? Those are the 2 different questions you have to answer. If we're getting volunteers, then they weren't randomly selected, and that could cause some issues. Okay, so if they weren't randomly selected, we can't infer about the population. We can't make, all we can do is infer about that group of people that we did the experiment or that we sampled or that we performed the study on. Okay, so random selection is important. And then we randomly assign them to two different groups usually, or more, can be more groups, but you need a treatment group and you need a control group. So if they were randomly assigned that way, then yes, you can infer about the population. So those are the two key things. You want to be able to infer about the population, but you also want to be able to get cause and effect. The best thing is the left uppermost box, left at the top. They were randomly assigned to the treatment groups and they were randomly selected. Okay, I'm not going to read through everything, but that beginning part was really important for us to look at. When you do an observational study, if you don't randomly assign, that rules out inference about cause and effect. Typically, in observational study, you can't make causation. It's usually from an experiment, but there are some exceptions. I'm going to let you read through these examples. I'm not going to read through all of them. These are some designs. And then the answers are on the next page, but take some time to look through them. You have the notes in front of you. It's important to do that. Again, I'm not going to read through every single little thing. That doesn't mean that it's not important, but I don't want to just read a PowerPoint or something to you. Ethics. In some cases, it's not practical to do an experiment. It's not. So we have to be aware that sometimes we're going to say cause and effect, but we're kind of stepping out on a limb a little bit. So we need to be careful with those kind of things, and these are some examples of that. Okay. So we want to be able to do cause and effect. This causes that, but we can't always do that. So when you do an experiment and people were randomly selected to be in the experiment and people randomly assigned to the treatment groups, that's when you can establish cause and effect. That's the perfect world situation. But what happens if it's not an experiment? If it's just a sampling, it's a study, can you do causation? It's a lot more difficult. These are the conditions you must make. There must be a strong association. The association is consistent. Larger values of the explanatory variable associated with stronger responses. So using the cigarette example, we need to apply it here. So the evidence that smoking causes lung cancer is so strong that the U.S. Surgeon General states that cigarette smoking is the largest avoidable cause of death and disability in the United States. The evidence for causation is overwhelming, but it is not as strong as the evidence provided by well-designed experiments. So, just looking at a study, we like to try to get causation, but it's still, an experiment would be better. But it's tough to do an experiment, force people to smoke and force people not to smoke and be part of it. So here's some examples. Go ahead, you can take a look at those. So ethics, when you're doing an experiment, that's when you can have more severe things if you're not following proper guidelines to do an experiment. HIPAA violations, right to know laws. There are certain laws that must be followed to do certain types of experiments. So we just need to be aware of that. Not that you're going to be doing experiments, but it's possible someday that your job may involve collecting data of some kind. All planned studies must be reviewed in advance by an institutional review board. So that's just one of the things. It's one thing when you're providing a treatment, you're giving somebody a treatment. All individuals who are subjects in a study must be given informed consent. So they must allow you to do that. And then the confidentiality piece. So basically you can't collect data off of people if they don't know you're collecting it. That's what informed consent means. And then you can't tell everybody else, oh, this is what this specific person did or had happened to them. some of the stuff is a little bit self-explanatory, and some of the stuff won't be on the AP test. It's just something that we should look at. Not everything is about just taking a test in this class. It's about preparing for possible life situations. Informed consent, they need to know ahead of time that it's going to happen. And then the confidentiality, you can't share other people's information. If I go to the doctor's not allowed to tell anybody about anything that I'm there for. So the challenges of establishing causation, we'd love to establish causation, but it's typically we need an experiment to do that. Well-designed experiment tells us that changes in the explanatory variable cause changes in the response. That's the x and y. If you think back to algebra, linear relationship, when x goes up, y goes up, that's like a slope, or when x goes up, y goes down, that's a slope. So we just need to be aware of that. So, cause and effect, ethics, you just need to be aware of those. The cause and effect piece is something that can be tested. The ethics part doesn't usually come up, but it's something that's important for us moving forward, just to cover our bases. So, if you have any questions, let me know, and you'll have an assignment to follow.